were and where do we go from here. And then we'll go through the questions. There's 1 or 2 questions for each of you, so then we'll go through the questions as well. All right, so Brian,
did you launch those slides? Get those slides up?
Post them up.
Okay.
And I'll kick it off whenever Brian gives me the green light, I guess.
Have fun, guys.
Hey, BH, thanks.
Hey. Thank you for doing this.
Sure.
Hey, Jeff, just keep an eye on the attendees number, and when that sort of levels out, that would be a good time to kick things off.
Yeah, I see it's up to 60. Okay, we're approaching about 100 participants, so I'll go ahead and get started. This is session number 3 of the CMAS conference, titled Emissions, Inventories, Models, and Processes. Brief session agenda on this slide. We're going to go give you a session introduction. Co-chairs, myself, Jeff Vukovich of US EPA, and Adelman of LADCO are your co-chairs. We have 18 speakers, so we have a pretty tight schedule. Zach will take us through a summary of the session, of the presentations, and then each one of the presenters will have a chance to quickly summarize in a couple minutes their talk, and then we'll have a question. We have questions for each. And if there's any time left over, we'll have some discussion. Next slide.
Thanks, Jeff. Let me just start by acknowledging and thanking the CMAS organizers for creating this online conference platform for us. I think it's really phenomenal what you guys have pulled off here. You know, we miss being at the Friday Center and being here in person, but, you know, given the circumstances, you guys have done a really fantastic job. So, you know, kudos to all of you at CMAS for organizing this. So Jeff and I, as we looked through the presentations in this session, we saw that they were kind of organized into 4 main categories: talks that touched on inventory development, modeling, emissions evaluation, / remote sensing or using remote sensing information to evaluate emissions data and improve emissions data, and then emissions tools. And so what we'll do is we'll go through the talks. You know, hopefully people have had a chance to look at and view the pre-recorded talks, and the speakers, you all did a fantastic job in getting your presentations recorded. I was really impressed, not just with the content, but with the quality of the recordings. So each of the speakers will have a couple of minutes to summarize their work. And then we have a couple of questions for each of them. And then as questions come up from the audience, we'll field those as well for each speaker. So from the inventory development, we'll start here. We have 5 talks that talked about different aspects of developing inventories, putting inventories data together for modeling and analysis. And so we'll go through these talks now. We'll start off with Swetaleena Dash, some work that she did on inventories in India. Allison will talk about the 2017 modeling platform. Amina Sani will talk about some inventory development work that he did in Iran. George Pulyu will give us an overview of some work that he did with developing a kind of historical fire inventories. And then Poonam Mangraj will talk about some work that she did developing inventories in India as well. In the emissions modeling session, Sebastian Cano will talk about some modeling work that he did for inventories in South America and Colombia. Kristen Foley will talk about some emissions, air quality and modeling data that she put together at US EPA. Lena, you and Flavia will also talk about work that she did, that they did modeling different aspects of emissions. And then we have 6 talks that go through remote sensing and using satellite data to improve, constrain, and evaluate emissions inventory data. And then we'll wrap up with some talks on emissions tools, some utilities and tools that have been developed to develop emissions data and improve inventories and emissions ancillary data. So Swetaleena, are you online? Can we hear your audio?
Hello.
Hi.
Hi.
Please give us a brief summary of your work.
Yeah. So hello, everyone. I hope everyone is safe and fine during this major COVID outbreak everywhere across the globe. So as suggested to summarize my work, I would note down a little bit idea about my work. So as we know, India being a developing country, it faces major environmental issues today. Huge density population, almost around 1.3 billion, imposes a critical factor for the production as well as management of the municipal solid waste. However, poor collection, segregation practices leads to improper management of this MSW, leading to a mass open burning of the waste here and there. So to specify the assessment of how much waste is burned to open and the emission of critical pollutants from this not so attended sector is the key reason behind this piece of research. So this possible research covers all the possible MSW generation as well as landfill sites across the India by taking factors like per capita production, waste disposal practices, and population dependent factors into consideration for emission estimation. So emissions of 7 major pollutants of different 7 major pollutants have been spatially allocated and gridded into a much finer resolution of 0.1 degree grid scale. So this particular study can be used in atmospheric models and can be useful for proposing various guidelines or measures for environmental pollution control strategies in this developing country. I hope that helped. Thank you.
Jeff, I think you're muted.
Sorry about that. Yeah, the questions on this slide or on this talk were, what is the monthly distribution of burning in India?
Yeah, to begin with the question assigned for the supplied presentation, I would like to answer the first one, that is the monthly distribution. So yes, we have covered the monthly distribution pattern across India, and it is varying significantly according to the seasonality pattern. Our study demonstrates that the maximum emission is seen during the months from October to January. Almost 45% of the total emission is seen during the span of these 4 months, followed by the dry months of India, that is primarily from March to May, and least one being the monsoon days. So this is the seasonality variation as well as the monthly variation for our work.
Great. And have you had a chance to compare your work versus the other open burning emission inventories on the global scale for your region?
So the second question, as it suggests, that whether we have compared our studies to any of the global scale inventories or not. As we have developed this inventory only specific to the MSW burning, there is no such clear defined sector in the global scenario. Rather, there is a sector called biomass burning, which includes all the possible crop residues or other other waste particles to that sector. So we have composed our study and compared it to some of the past Indian studies like Sharma et al., like CPCB annual reports, and Vedenmer et al., which specifies to only MSW burning sector. So this work is incorporating by this work is done by incorporating all the possible these kind of studies.
Great.
Yeah.
For your answers.
Thank you.
have to
Thank you.
move on
I
to
hope
the
it
next
helped.
one.
Yeah.
Move on to the next slide. Our next presentation, our next presenter is Allison Height on the development of 2017 emissions modeling platform. Go ahead, Allison.
Hey, thanks, Jeff. My talk is on the development of a 2017 emissions modeling platform that is based on the 2017 NEI that was released earlier this year. And this was developed as part of a long-term collaborative project with the Centers for Disease Control and Prevention. And we are also using it to review model performance for field study areas in 2017. In the talk, we show the inventory as compared to the 2016 V1 collaborative inventory, both in aggregate for all the pollutants and by sector. And nationally, we found that the total NOx and SO2 emissions are slightly lower in 2017, while other criteria pollutants were higher. But keep in mind that all pollutants show increases in some areas and decreases in other areas. The total emissions for many of the point and mobile sectors were found to be lower in 2017 than in 2016, but emissions from fires, oil and gas, and non-point sources went up. And in the second half of the presentation, I go into some sector-specific comparisons. The platform is posted on our emissions modeling FTP site and soon will be linked from our website. And also, I wanted to make a point that in October, the CMAS Center has just released new versions of Smoke and of the speciation tool. And also in November, we expect a new release of the surrogate tool that's based on Postgres. So keep an eye out for that. Our future work would involve closer examination of the model performance and also a run that includes HAPs, more HAPs than the hazardous air pollutants, I should say, than the CDC run did. And we're looking at some speciation related improvements. We'll soon be moving on to 2018 platform development. And I wanted to note that we've posted some early versions, not our final versions, but early versions of the 2018 point source inventory and also fire inventories on our FTP site. Do you want me to go ahead and answer the question that's posted?
Yes, go ahead. Yeah, please go ahead.
Okay. So as far as updates go, we did notice after we did our modeling for the CDC that as part of the NEI process, we found that the airport emissions were overestimated in the released version of the NEI. And we have corrected inventory, 2017 inventory available that has the improved emissions on our FTP site, but it's not in what we used for CDC. And we've also had some specific point source corrections loaded into the emissions inventory system since we did our modeling. And we're also planning to look more carefully at hazardous air pollutants. So there might be released in another package, but we kind of have to wait and see whether we go ahead and do that.
Great, thank you, Allison. Let's move on to the next presenter.
Well, we have a question for Dr. Dash, Swetaleena. Maybe we should do that before we move on.
Okay.
So Tesh Rao asks from the previous presentation, Dr. Dash, are your emissions estimates being fed into regional databases like EDGAR RAIN so that they're available for global modeling needs in the general community?
Are you on? Are you still on, and are you on mute?
Yeah, you might be muted, Swetaleena. There you go.
Hello? Am I audible? Hello?
Yeah, there you go.
Hello?
I can hear you.
Yeah. So, actually the question that is for me, actually, these emissions estimates are not yet being included in the databases like EDGAR or RAINS, because this is a comparatively newer study, and we are still working on it. And once they are completely done with more modified versions, we will definitely love to do that.
Okay, thank you.
Great.
Any questions for Allison before we move?
I don't see any.
Okay, Min Hassani, can you unmute your mic and give us a summary of your work?
Hello, everyone. Do you hear me?
Yep.
So, first of all, I want to thank for the opportunity. We developed a web-based emission inventory system in order to address fast and easy update of emission inventory in Tehran, as well as producing the output required for photochemical models such as CMAS and CMAS. The system covers both regulated pollutants and GHG emissions from multiple sources, including mobile and stationary sources, such as power plants, refineries, bus terminals, airports, and railways, gas stations. And the point is that any person with a minimum technical background could enter the detailed inputs in a very simple and easy format to the system, and the system will produce some GIS-based results which support multiple time resolutions. Moreover, the system benefits from an enhanced reporting system that is capable of producing emission maps and time series reports, as well as specifying shares of various sources. And another point is that the system is modular, so the user can run if-then scenarios or switch among data from various sources easily. We run this system in order to develop emission inventory of Tehran in 2018, and the paper will be published soon. However, this system can be used for any other city or even in other countries easily, and there's no problem for that. And in the future, we are going to add multiple options for the mobile source and reform calculation methodology for some stationary sectors such as industry and refineries. I hope I
Yeah,
can
that's great.
Shall I answer the question?
Sure. Have you used this calculation model outside of Tehran?
No, we haven't used this model for outside Tehran, but as I told, as I said, everyone can use it for different cities, and there's no problem for it. Okay.
Thank you.
No questions so far.
All right. We'll move to the next talk. George Lyu. Oh, sorry.
Hello.
There we go.
Yeah, my talk is about a multi-year reanalysis of the EPA's fire emissions inventory. And this is part of a larger project that the EPA is doing to do a reanalysis of emissions inventories from 2002 to 2017. And the full description of that work is in Kristen Foley's talk later in this session. So if you want the full analysis, my focus was just on the fire inventory. And the purpose was basically, in a short, purpose of the work was to get a consistent methodology used for all the years. So we use the same data sets to the extent possible and apply the same methods across all the years so that the fire emissions would be comparable across years. You would actually be able to determine a trend that's due to the data, not due to changes in methods. And yes, we will use this data will become available for researchers. I'm not sure what the question, there's a question about air quality planning projects, and I'm not quite sure what they're referring to, but the data will become available for CMAC modeling. And I guess whatever the modeler wants to use, that would be the purpose.
Great, thanks, George. Nice summary and quick. You addressed the questions as well, so I appreciate that. So we don't see any other questions coming in, but feel free, as we're moving through here, folks, to ask questions as they come up. This next summary will come from Poonam Mangaraj on some work that she did on developing inventories for India.
Hello, am I audible?
Sounds good.
Yeah. So my name is Poonam Mangaraj. I'm working as a PhD research scholar in Utkal University, Bhubaneswar, that is located in India. So my research work basically focuses on understanding the scenario of air pollution, basically in mega cities, and analyzing them and developing most reliable emission inventory data sets. So working along the line, I can say that understanding and identifying the sources of emission are the most important initiatives in order to suffice the requirement of air quality management. So my work here could also possibly be used to ascertain the impacts on air quality, human health, and environment as well, which could possibly further be used in deriving mitigation strategies. And addressing to the question here mentioned, I would like to go one by one. First question was regarding the comparison of inventory with the previous works. So yes, we have compared this inventory to the previous ones like that with of EDGAR 2015, Intex B 2006, O'Hara et al 2007, and etc. And these works have been done for the older base years. So I can see that our study proves to be the most reliable, as this has been done for the most recent base year, that is 2018, with a higher resolution of 0.1 degree. And we have adopted the most recent authentic government data with respect to vehicle statistical data. Also, number of field surveys and campaigns had also been carried out in Indian mega cities like Delhi, Mumbai, Ahmedabad, etc., in order to quality check the real-time scenario and serve the better purpose of developing a reliable emission inventory data set. Following the second part of the question, it's a very large question actually. So the second part goes with regarding the pie chart that I had mentioned in my slides. Here actually I have shown only the number of vehicles per category that relatively contribute to the total number of vehicles running on road in India, where we can see clearly that two-wheelers and personal cars are found to be higher. So the purpose of showing this pie chart was only to portray that India has recently been witnessing an upsurging demand of two-wheelers and personal cars. I hope that helped the second part. And the third part was if the two-wheelers are the largest sources of emissions. So again, I would say that this varies actually from pollutant to pollutant. According to specific pollutant type, the contribution of different vehicle categories would definitely change significantly. So the largest vehicle category is actually not necessarily meant to be the largest source for all type of pollutants. As we know that some vehicle may emit more PM, some may emit more CO. So the relative contribution would vary if we change the variables according to the VKT or age of specific vehicle or emissions, because all of these parameters are independent in themselves. So I hope this helped in addressing the question.
Yeah, thank you. That's a nice summary.
Thank you.
Poonam, you got a couple of questions. We're going to keep moving forward so everybody has a chance to present their talks, and then we'll loop back the questions at the end. So
yes, sure.
With us, please.
Yeah.
Thank you for that.
Thank you. Thank you.
Hello, can you hear me?
Yes, we can hear you. Go ahead, Sebastian.
Okay, let's start. In Colombia and Bogota, we want to use an air quality model that serves as an input for decision maker. Unfortunately, we only have a high resolution inventories for a few cities. So we have to use a low resolution inventories outside the cities, such as EDGAR emission, for example. Within the city, the simulation has a good performance, but when we look the concentration in the urban perimeter, it's where we don't have a good performance compared with observation. We think that this is due to the lack of emission around the urban perimeter that are densely populated. To improve our simulation, we decide to change the spatial distribution of EDGAR emission, but only emission from industrial, mobile, and residential sources outside the urban perimeter, according to the population. Emit where the population is located. In this way, we improve our simulation in the urban perimeter of the city. And answer the question?
Yes, please.
Okay.
Do you know, the question is, do you know of any new efforts to estimate emissions for your region with a bottom-up approach using the recent population data you mentioned in your talk?
Okay, it's a good question. Unfortunately, no. In Bogota, it's possible to calculate the emission using population data, number of vehicles, and industry, and apply bottom-up methodology. In fact, we thought to calculate the emission in this way outside the urban area because we already have the population data. But it's difficult to get information about number of vehicles and industrial in each population center or in each town. And it would be interesting to use bottom-up methodology using population data to calculate the emission inside the urban area. And that's it.
Okay, thank you very much. And we'll save any questions again for the end. We've got to keep moving forward here. So next up is Kristen Foley. Go ahead, Kristen.
Thanks, Jeff. So this presentation is a status update on the EPA's air quality time series project that we're calling Equates. And this represents the work of a large team of modelers at EPA, meteorological, emissions, and air quality modelers, not just myself. So as George alluded to, the goal of the project is 16 years of CMAS simulations, 2002 through 2017, over the Northern Hemisphere and the continental US. And these simulations will supersede some previous decadal simulations that we've produced and that have been really widely used, but are now outdated in various ways. So our simulations will use CMAC version 5.3.2, which was just released this month, and includes many advancements since the last time series, which used version 5.02. It will have a new consistent set of meteorological inputs. And what's relevant to this session is the development of new emissions inputs for these 16 years using consistent methods to the extent possible. So the slides provide more details on how we're treating the different emission sectors for both domains. But some highlights to mention are the new fire emissions that George already spoke about, new emissions inventory for volatile chemical products that you're going to hear Karl speak on very soon. Also new on-road mobile emissions from EPA's MOVES 3 model that's going to be released this year. So these simulations the CMAC simulations are going to begin soon. And then once they're complete, the deposition estimates will be used for multiple EPA tools and products, such as TDEP and EnviroAtlas and Critical Loads Mapper. And then the air quality trends for the many other pollutants that CMAC estimates can be used for epidemiological studies and other human health or ecological applications. So we are planning to publicly share subsets of the model inputs and outputs in 2021, so stay tuned for that. We hope that this really rich data set can be used by the CMAS community for a wide range of studies. So I saw the question is, once we finish 2002 through 2017, will we be adding on to 2018 and 2019? That's a good question. We will eventually be modeling those years. I can't say that they'll be precisely consistent with this set. I could see maybe there would be some changes in the inputs, but I don't think they'd be significant. I think it'll be more of an issue when we get to a new NEI year or a new major release of CMAQ. And so we have already started talking about how we can sort of operationalize this process of regenerating these time series and do it on a more regular basis. So those are good questions. Thanks.
Thanks. All right, Lena, you're next. Go ahead.
Okay. Hi, everyone. I'm Lena, a graduate student from Russ University. And our project is enhance the representation of agricultural emissions of reactive nitrogen in fertilizer emissions scenario 2 for CMAQ FAST-C. So fertilizer-intensive agriculture has become the largest source of reactive nitrogen emissions in the United States. Almost half of added nitrogen on croplands is lost to the environment in multiple reactive forms, including the air pollutants, ammonia, and nitrous oxide, NO, and also a potent greenhouse gas, nitrous oxide. Some farming practices, such as fertilizer management, could reduce emissions of all forms of reactive nitrogen species, while others, such as no-tillage, could generate trade-offs among different species. So there is a need to not only predict nitrogen emissions from soil, but also indicate how these emissions vary with different farming practices. Currently, the soil nitrogen schemes in CMAQ, including the bidirectional ammonia scheme and the mechanistic nitrogen scheme, have improved the prediction of reactive nitrogen emissions from soils by linking with the FAST-C. However, such linking is not in a dynamic and consistent way to reflect changes of soil properties with farming practices, resulting in limitations to predicting how nitrogen emissions respond to farming practices. So in our study, instead of linking FAST-C and CMAQ, we directly use FAST-C with modifications to its nitrification and denitrification processes to predict ammonia, NO, HONO, and NTO emissions from agricultural soils. Compared with the existing nitrogen schemes in CMAQ, the enhanced FAST-C shows a better performance to predict NO and NTO emissions against the observations. However, there needs a further evaluation of ammonia predictions with more observations to identify if there is a need to modify the volatilization processes in FAST-C. In future, we will use the enhanced FAST-C to identify which farming practice can yield co-benefits for addressing air quality and climate concerns. That's a quick summary of our research. So for the questions, there are plans to examine results versus observations for additional years. That's a very good question. Currently, we only compare our simulation results with limited observations, and most of them were collected 10 years ago, especially for the NOx emissions. Yeah, we want to evaluate our simulation results with observations for additional years, especially the same year we simulated. However, there are very limited field environments published available for our comparison, especially ammonia and NOx. So we expect more research published and help us to evaluate and improve the current nitrogen scheme in FAST-C. Thanks.
Thank you. All right, and next we'll hear from Yu Marino on some work he did on condensable particulate matter from stationary combustion sources. Yu, take it away.
Yeah, can you hear me?
Good.
Yeah, thank you. My presentation is about estimation of condensable PM emissions from stationary combustion sources with particular focus on organic aerosol. In the conventional emission surveys, particulate matter was occasionally sampled without dilution or cooling. Therefore, thin volatile compounds, so-called condensable PM, cannot be measured. So condensable PM is not consistently included even in the latest emission inventory. One very important issue is that there are two methods for the measurement of condensable PM, and recent studies indicated that we need to use dilution sampling method and not dry impinger method. Another important issue is that for the estimate of condensable PM emissions, we need to consider the relationship that fraction of condensable PM was higher at sources with lower filterable PM concentrations. With this consideration, we estimated that organic aerosol emissions increased by 28% by including condensable PM. So this is the summary. And to answer the first question, one hypothesis is that filterable PM concentration at the end of stack was lower at sources with the latest after treatment device. And removal efficiency of low volatility filterable PM could be higher than the removal efficiency of same volatile condensable PM. So I think this could be an answer to the second question as well. So that's it.
Great. Thank you, Yu. Nice presentation. The next talk is by Flavia Ribeiro on some work that they've done on vehicular emissions in Sao Paulo. Take it away, Flavia.
Hello, everybody. Well, our research about future scenarios had the motivation, had as motivation the need to evaluate urban planning public policies that are appearing in the city and in the state of Sao Paulo, and also to see their impact in air quality and also greenhouse gases and anthropogenic heat emission. And some key lessons, some things we already knew is that we need to invest more on infrastructure for public transportation and also in the use of biofuels and research about biofuels. And also we need to consider, the public policies need to consider several aspects, not just air quality or just climate change mitigation or just heat, but them combined because different strategies have different outcomes. And for next steps, we want to discuss some strategies and their impact and also to estimate economic and health costs and benefits for each strategy or for some of them combined. So for the questions, in your future modeling scenarios, are you able to parse the impacts of the different strategy components on the emission totals? For example, sorry.
Sorry about that.
It's okay. For example, do you know the relative impacts of electrification versus mode switching versus biofuels? Yes, we can evaluate each strategy separately and also combine them as we wish. So 2, 3 or more strategies. Here I only showed no strategy or all of them combined, but we have evaluated them separately. And the results are different for different pollutants. For example, electrification and the use of ethanol in passenger cars help decrease CO, also help to decrease VOCs and anthropogenic heat, and also CO2 equivalent emissions. But some other pollutants have different behaviors. For example, particulate matter is more impacted by the renewal of the fleet than by any of the strategies that we used. So the renewal of the fleet, the actual program for controlling emissions, particularly for buses and trucks, is more efficient than any of the strategies that we tried. But well, we can try other strategies as well. I think that's it. Thank you.
Great. Thank you, Flavia. Let me mention to the panelists, so we can keep things moving. We're getting some good questions in. Panelists, as I mentioned in the chat box to you guys, if you could go to the Q&A, you'll see that there's a series of questions. Poonam is answering some of the questions directed at her now. If the rest of you can find the questions that are out there, Dr. Luo and you guys have a couple of questions out there, Lena as well. If you could answer those by typing into the Q&A box, it'll help us keep the session going.
All right, Nicholas, you're up next.
All right, great, thanks a lot. So this study was motivated by the fact that we can observe ammonia from space using the cross-track infrared spectrometer, or CRIS instrument. So the goal of the project was to take the observations from CRIS and apply them in a finite difference mass balance inversion technique to improve emissions of ammonia. And so we did this in CMAC for June 2015. The main finding was that the ammonia emissions were considerably underestimated in CMAC, and that just one iteration of the inversion process led to better agreement with the CRIS observations themselves. But future work, we're going to be doing a more extensive evaluation against independent data sets. We're currently in the process of updating CMAC to version 5.3.2, and we're also going to include the ammonia bidirectional flux, which wasn't included in the presentation, what was shown in the presentation. And as part of that, we are updating the emissions platform, which I see is one of the questions. So that is something we're definitely addressing. And the final goal of the project is to have all of this automated on Amazon Web Services, so that all of you in the air quality modeling community can get these updated emissions for your model or in your platform for the month or weeks or whatever time period you're interested in. And for the second question, so we do have 5 years of WRF data ready for this process, and basically we're just still getting everything working correctly, and as we're updating the models, we're just trying to make sure everything's working right before we do that. But we do have a lot more meteorology data to run this, so yes, hopefully we plan to do this for a much longer time period to make the evaluation more robust.
Great. Thanks, Nicholas, for the summary and answering the questions. You're up next.
Yeah. Hello, everybody. I'm Hossein Khajapour, a graduated researcher from the Sharif University of Technology, Department of Energy Engineering. Our research work, our question was to identify how reliable are the emission inventory results for the environmental management in mega cities, which in cases which there are specific meteorological or topographic characteristics of the area. And also in cases such as Tehran, we can see that the emission sources, different types of emission sources are distributed around the city and inside the city, so they can't have, the same contribution to the air pollution in the residential district. So we tried to identify the difference between the results of the source apportionment and the emission inventories to check them with the sensitivity analysis of the concentration to the different emission sources. Therefore, we have developed an emission inventory according to the gains emission factors and the activity data which were available for the year 2010. We have done the modeling through the ADMS urban model, and we validated the modeling results with some of the air quality monitoring stations in the city. And at the end, we did the sensitivity analysis of the main emission sources by identifying the contribution of each one of those sources in the concentration in the sampling area. The results were quite, quite interesting for us, because we have seen different results between the source apportionments and the emission inventories, and the sensitivity analysis also were inconsistent with the source apportionments results. Our data were for the year 2010. So for the future works, first of all, we intend to update our models and emission inventory and the analysis, and also to have the same study for different districts in the city. We have just studied the district where the Sharif University is located in west of Tehran. Also, we intend to use other types of the other models in order to account for the secondary PM2.5 formations. And also, when we have this sensitivity analysis tool, we can evaluate the environmental management policies in the city. That was a brief summary of our work. Can I go through the questions?
Yes, please.
Why don't you take the first one, Hussein, so we can keep things moving?
Yeah.
Yes. Yeah, our dispersion modeling, yes, it was accounting for different meteorological and topographic conditions. Characteristics such as wind speed and direction were taken into account. And regarding the details of the mobile inventory in Tehran, actually, our data is quite outdated. It is the available data which we use from the Tehran municipality reports, official reports, were presenting the different types, the usage of different modes of transportation in the city for the year 2010, but different modes were accounted. And the details are presented in the charts in our presentation and the paper. But if any further details are requested here, I can give some numbers. Over to you.
Great, thank you so much for the summary and answering the questions. Go for the next. Ming, you're up next.
Thanks, Jeff. This is Congmeng from Reactive University. So for this project, it is a data simulation project in which we use a Python-based four-dimensional variational framework with CMAS and is urgent to constrain ammonia emissions with observations from satellite. We choose to refine ammonia emissions because the knowledge of the magnitude of ammonia emissions is severely limited, and this hinders efforts to address the ammonia-related human health and ecosystem issues. So the current observation system simulation experiment, OC, conducted in this project gives promising results. It demonstrates that the ability of the 40VAR framework to constrain ammonia emissions using simulated satellite observations is good. And but 40VAR is very computationally expensive. So we are evaluating a hybrid invariant framework that combines finite different mass balance and 40VAR because finite different mass balance runs faster than 40VAR. So we're expecting that this hybrid invariant framework to be more efficient. And for our future works, it includes conducting an OC, the observation system simulation experiment for the hybrid framework. And after this OC is thoroughly evaluated, we will port the framework to a 2017 modeling platform for the simulation of real crisp satellite observations. And we will select 3 suitable periods from April through October of 2017 for the real simulation and refinement of ammonia emissions. And after this refinement inversion of ammonia emissions, we will also use ground-based observations to evaluate the refined ammonia emissions to make sure that the quality of the inversion is good enough. So a more accurate ammonia emission inventory will benefit the studies focusing on topics such as PM2.5 health impacts and ammonia ecosystem impacts, etc. Since these studies will rely on the accuracy of ammonia emissions inventory to do modeling simulations. And this is a summary of the project. And as for this question, the answer is yes. Our ultimate goal is to refine ammonia emissions for the continental US on the 36-kilometer resolution. So you will have the final product for the continental US. Yes, thanks.
Thanks, Congmeng. And thanks to the panelists who are actively answering questions in the Q&A. Please keep it up. Thanks. Okay, the next presentation is from Nasime Shiroki about some work she did on inventories in Tehran. Take it away, Nasime.
Hi, this is Nasime from the University of Melbourne. Yeah, in summary, we are working on improving urban emission inventories using 4D VAR data assimilation and Terraform satellite dataset. We prepared our a priori emission inventory by downscaling the EDGAR data set, applying population data set as praxies to have a final resolution emission data. We ran the forward model, which is offline WRF CMAS modeling system with our a priori emission inventory. Then we compared the result with independent satellite and surface data. To minimize the mismatches between model outputs and satellite data, we applied the Terraform dataset to establish inverse framework. Currently, we are working on preliminary outputs of inverse model for CO in Tehran to evaluate how much improvement is happening in the first try. And then we will apply this framework for other species and urban areas in the future. Now I'm going to answer this question, but feel free to post more questions in the chat box if you have any. And yes, Tehran has a complex terrain, and we did have problem with numerical stability for a while at first. But we applied more than 20 scenarios in WRF modeling to find out the best physics and dynamics schemes for this city. The selected scheme could capture the temperature, relative humidity, and wind direction very well. But sometimes the model underestimates the wind speed, but overall, the scheme is capable enough to be applied in our study, and we were confident enough to use this scheme for the rest of our study. And yes, Tehran is subject to temperature inversion. This is not something that we looked at before, but when I see this question, I try to have a plot of time series of between surface and different layers. And I can say that yes, as we expect temperature inversion during cold nights, I try to make plot for some days in February 2019, and yeah, we could easily see that model capture the temperature inversion.
Great.
Yeah,
Thank you,
that's
Nessa. Thank you so much. Okay, and now we'll hear from Amir Suri on some work that he's done with using joint inversions for NOx and MVOC emissions using satellite observations.
Hey, this is Amir Suri. I'm a scientist at Harvard Smithsonian working with Tempo Science team. So in a presentation, I said I mostly cover some results from a very recent study work on dealing with constraining both NOx and VOC emission using satellite observation over East Asia. So we know that in order to reproduce atmospheric composition, we need reliable emission inventories, and those usually have large uncertainty. So we really need to update and constrain them using independent measurements. And one way is to use satellite observation to provide a constraint on those quantities. So what we did, we jointly use ARMS formaldehyde and tropospheric NO2 to constrain NOx and VOC at the same time, and that benefited our study in 3 ways. First, we were able to constrain ozone production rate because ozone pollution obviously is a nonlinear function of those quantities. And also we explicitly considered the cross relationship between NOx, formaldehyde, and VOC and NO2 because we incrementally optimizing the inversion. And also we show various changes in the ozone pollution as a result of the recent regulation happening over China, Japan, and South Korea. So some of major results I found out was that, okay, we observe a huge change, a decline in NOx emission over China because of the fact that government there, they shut down a lot of power plants. Whereas, for example, in Japan, we found out the NOx emission increased by 12 to 20% because they substitute the Fukushima nuclear power plant with a lot of thermal power in the rural areas. So we saw a lot of signs and large variability associated with change in NOx, and we saw a lot of change in VOC. We found out that China didn't do that much effort to reduce VOC emission in North China Plain. As a result of that, we saw a huge enhancement of ozone pollution by 5 ppb over surface area. So yeah, this type of practice were very helpful to show how emission change, ozone pollution, and pertain and any relevant chemical pathway for ozone production and loss. So in terms of the question that, okay, how can we operationalize that for the other agencies? The fact that I use this method in analytical way makes it very computation expensive. But we submitted a proposal 2-3 months ago with collaboration with NOAA to expand this analysis and do some sort of Monte Carlo approximation of Bayesian inversion by doing a local ensemble Kalman filter, and that's more practical to do it because it's easier to make it parallel and then still be able to incorporate multi-sensor, multi-species framework.
Great. Thanks, Amir. I look forward to seeing any follow-up from that.
Thank you.
Okay, next we'll hear from Sina Vostani about some work that he's done using analytical methods to improve CMAC methane emissions. Take it away, Sina.
Hi, everyone. This is Sina. Thanks for having me. In this study, which is part of my PhD research at Carleton University that I'm currently working in collaboration with Environment Canada, basically we're developing these inversion frameworks with the statistical capabilities with the aim to evaluate and further improve the methane emission inventory. This is an ongoing project, and in the first step, we need to show that these methods can work properly. So for this, we developed an Aussie framework to evaluate the performance of the framework along the capacity of the satellite observation from different sources and in combination together to constrain the methane emission. In response to the question, whether we can use these methods to monitor the methane emission according to regulation. I would say, first of all, it depends on the scale of the problem. So far, our spatial scale is at the level of the states. It means that we get 52 updated emission factors at every time interval for each source sector. The source sector, which are based on the EPA source categories for methane. We also found that with the temporal scale of about a month, we see a good agreement between the updated and true emissions in Aussie tests. This level of spatial and temporal correction can go along with the emission control programs. And in addition to this, the scheme provides an estimation of error propagating in time that is a sort of an error bar of the emission estimates. Having these emission factors plus the errors also might help to fill the gap in quantifying the emission of the methane for control programs. And lastly, in our next step of our research, we are going to apply this method in a real observation context and address other possibilities such as the estimation of the observation error and model error and so on. I hope that answered questions.
Yeah,
thank you.
That's great. Thank you, Sina. In our next talk, we're now getting into the last two talks of the session. We'll hear from Karl Seltzer now on some work that he's done developing a tool for VCPs. Karl?
Thanks, Zach. Hi, my name is Karl Seltzer, and I'd like to begin by thanking Zach and Jeff for helping facilitate this discussion. So in urban environments, volatile chemical products, or VCPs, are considered the dominant anthropogenic source of organic emissions. And so this, of course, has implications for SOA and ozone. So VCP emissions have long been accounted for in the EPA's National Emission Inventory as a solvent sector. However, new inventory methods have suggested that the NEI could be low bias. And so as the influence of VCPs on secondary air pollution grows in relevance, it becomes increasingly important to resolve these differences. And so what we have done is we developed a new framework to model VCP emissions throughout the United States and have called it VCPI. We also quantified the emission volatility distributions of various product use categories, tested a variety of the different uncertain parameters through Monte Carlo analysis, and evaluated the inventory using ambient observations. And so notably at the national level, VC-PI emissions are broadly consistent with the EPA's 2017 NEI. However, county level and categorical estimates can differ substantially. And in addition, an observational analysis or evaluation indicates high fidelity in the methods that we employed. As for the questions, one, have you thought about how to include primary formaldehyde and acetaldehyde in the output from the tool? Well, first, consumer and commercial chemical product surveys don't report the presence of aldehydes in at least appreciable quantities. And so perhaps the questioner was referring to, I don't know, for example, formaldehyde emissions from household articles such as wooden products. And if that is indeed what the questioner was meaning to ask, we have not considered those possible sources yet. As for what will this tool be used for and will it inform future versions of the NEI? So first, I'd like to encourage everyone to watch Elise Pennington's talk from yesterday. I believe it's still posted in the model development session. And so that's an immediate application of these results, and it namely help inform model updates and better representation of SOA precursors and models. We also plan to apply these results in a national simulation to understand ozone and SOA impacts from VCPs. Let's see, the tool provided, so VCP also provided emissions for the Equates project that Kristen already highlighted. It's going to also replace the solvent tool and generate default emissions for the VCP/solvent sector starting with the 2020 NEI. And of course, we encourage any and all people that have an interest in VCPs to reach out, as we have a lot of data to share. So thanks.
All right. Thank you, Karl. And now we will hear from Madeline Strum about some updates to EPA's Speciate program and the speciation tool.
Thanks, Zach. Well, EPA develops and maintains the Speciate database that contains speciation profiles for VOC, PM, and other pollutants such as mercury that provide the composition of these data from emission sources. And these data are critical for creating emission inputs for air quality modeling, and there are many other uses in air quality management for profiles such as carbon inventories and source apportionment. And we very much rely heavily on the scientific community to produce the data needed to update and maintain the database. So we released Speciate 5.1 this past July, and we made a number of database improvements and added PM, VOC, and mercury profiles. We added PM profiles for fires, VOC for oil and gas, and mercury of many different mercury profiles. In my talk, I summarized those profiles in a little more detail and updates to the speciation tool 5.0, which is released now on CMAS, and that uses the Speciate database to create speciation ancillary files that are needed to be input into smoke. So another thing I do is review the sources of profiles that we use. A lot of them are from older versions of Speciate 3.2, 4.3, etc., and priority categories for which we need data. We are always in continuous need of data, and we like to be at these conferences to provide those needs. We do literature searches with the EPA library, but there's simply not sufficient published studies to provide complete speciation for all of our sources of interest. So we like to indicate what those sources are. And we also like folks to go back to their organizations to communicate, collaborate, and coordinate with their colleagues that can do research to produce these data or influence research to get source measurements to develop the speciation data we need. We've developed a data developer guide and Excel template for folks to get more details on what kind of the data we need and how to get it to us. And the great news is shout out to Utah who used this guide and provided us with Uinta Basin oil and gas profiles, which we added to Speciate 5.1. With regard to questions, we have integrated this speciation tool into the EMF, and the speciation tool has the Speciate database integrated into it. Now that for the speciation tool 5.0 uses Speciate 5.0 and not 5.1, so we'll need to update that. But there are ways to do that, and the user's guide provides that. That's not a heavy lift to put 5.1 in there. And with regard to addressing the data gaps, this conference, other conferences, we continue to make sure our needs are known. And of course, we're continuing to do our literature searches and work with our own Office of Research and Development on filling our data gaps.
Great. Thanks for that update, Madeline.
Thank you.
Well, that concludes this session. Big thanks to the presenters, the panelists, for doing this great work, presenting it to us, answering the questions live as we were going. That this was a very dynamic session. I think the most dynamic conference session I've ever been involved in, because we had people talking, we had people asking questions. This was really cool the way this platform worked out. Again, I know it's not ideal. We would be eating dessert in the Friday Center dining room right now. But otherwise, you know, I think this is a really nice platform. So thanks to everybody for your talks, for your great work. Thanks to Jeff for co-chairing with me. And again, another big shout out to CMAS for making this happen and letting us, you know, convene in this really tough time.
Yeah, I'll just echo the same thing that Jack said. We did have 18 questions during talks, and 17 have been answered, so it's been great. And if you get a chance and you haven't been able to look at you know, some of these talks in detail, please go back and look at the presentations and the slides when you get a chance. I also learned that the answers to your questions will be saved in a CSV file in case you're not able to get those. CMAS folks, you'll be able to provide that to them if they ask for it. Is that right?
That's right, Jeff.
Okay. Great. I don't have anything else. Please enjoy the break, and the next session, I believe, will start at 2. Thanks.
2 Eastern. Thanks for enjoy the rest of the conference, everyone. Thanks.
Thank you all.
Thanks.
Thanks. Jeff and
Thank
Zach.
you very much.
Thank you.
Thank you.